In this lesson, we're going to talk about how to create a barrel cam. Open up the barrel cam assembly from your Chapter 7 folder, and you'll notice right away we've got a couple of things to talk about. The first thing that we have to talk about is how to create the barrel cam itself. And the second thing to talk about is how to create the mates to make an assembly like this work. So let's open up the barrel cam. We started with just a simple cylindrical extrusion, and then we used the wrap feature to either add or remove material to the barrel cam. Within the wrap, you would use either emboss or deboss. Emboss is adding material, deboss is removing material. Also, within the wrap feature, notice that we've got a sketch. And if you remember back to our lesson on how to create a wrap, you just sketch a closed profile and then wrap it onto the face. Let's take a closer look at how to create that sketch. Your cam profile needs to be driven by transitions and dwell at various levels, and I'm not going to get into the details of cam design here. But in order to make the wrap work correctly, I made the two ends of the cam profile at the same level. And then I made sure that the length of the profile is shorter than the actual circumference, so that when it's wrapped, there's a gap in between the two ends. Now this accomplishes a couple of things, because you're not going to get this accurate enough just by using 100 decimal places to pi. I just open it up and leave the gap. Remember that the circumference, which is the length of the circular edge, is equal to the diameter times the constant pi, which is 3.1415, and so on. To close up this gap, it makes it easier if the two ends are at the same level, and so I just created an extrude. Using a sketch, the extrude goes up and finishes off the cam track very nicely. Also, in this part, I've added an axis. If you can get in the habit of using axes in all of your parts, it will make your life a lot easier, especially in rotating parts. Now let's flip back to the assembly and see how all of this was set up. Let's first look at the mates that are on the barrel cam. I'm going to suppress the follower and expand the barrel cam, and then expand the mates in barrel cam. So I've got two mates here. A coincident, which is plane to plane, the top plane of the part and the top plane of the assembly mated together. And then I have a coincident mate, which is the axis that goes through the center of the part and the assembly origin. So this produces the correct motion, which is just for the barrel cam to be able to spin in place without moving or tilting. So that works well. Now if we add the follower, I'll right-click on this again and set to resolve. That also reactivates the mate. The follower in this case is just a cylindrical end on a rectangular cross-section post. And then notice one other item. There's a sketch point at the bottom of the cam follower. Now this introduces a bit of inaccuracy, but unless you're doing motion analysis or real detailed time studies or things of that sort, this sort of motion will be okay for visual reference. It will probably not be okay for anything that requires a lot of accuracy, however. So let's take a look at how the follower was mated into place. We used the path mate, but we'll get to that eventually. In order to position the follower correctly, the top plane of the follower was made parallel to the top plane of the assembly. That allows it to move up and down, and then an axis through the part was made coincident with the front plane. So if we suppress the path mate, the only types of motion that are allowed at this point are for it to go up and down and in and out. We could constrain it further using reference geometry, maybe a distance mate from the end of the follower to the axis of the part, but the path mate does all of that for us. Let's first unsuppress the path mate and then edit it to see how it was created. The path mate requires a point on the follower and then a path selection. Let's actually delete the path mate and recreate it. So I'll pull this out of the way and let's create the path mate. Path mate can be found under the advanced mates and called path mate. Component vertex is this sketch point, and path selection is going to be this interior edge. Now the interior edge is actually made up of two edges because the wrap feature was just like a spline and it constitutes a single edge. But where we created the extrusion, that's a separate edge. So what we really need here is the selection manager. Remember that the selection manager is available on a right mouse click, selection manager. We want to click on the select closed loop, and if I click in here, it's not getting it. So let's use select group. We can select on that edge and this edge, and when we have the two selected, right click. SOLIDWORKS puts that closed group into the path selection and moves the follower onto the cam. From here, we can rotate the part. And I just want to point out, we were talking about inaccuracy. The greatest inaccuracy is going to be on the steepest slope. You will notice that because if this point is following the edge, then this sort of motion is only going to be correct if the cam face is entirely flat. And if the cam face is entirely flat, you don't have any need for a cam in the first place. So just be aware that using this method is inherently inaccurate to some extent. It may work for the purposes of a visual simulation, however.